I wouldn't, but yeah, just to let you guys know. All right, okay, welcome to the WA2 Overmark Sec 4 A Math session. So just to give a brief introduction, hi, I'm Miss Eileen. So yeah, as you can see here, I teach a lot of mathematics. Yeah, not like most of you care here lah, but just to let you guys know, I actually specialize in O-level and ITA math, and I have like at least 6 years worth of teaching experience. So don't be too worried if I'm gonna be, if you think that I'm gonna teach you anything wrongly lah. Okay, I won't. Okay, so yeah, and yeah. Usually y'all don't care lah, but in case your parents are wondering where you're learning all these details, or this where is this tuition center, who is the tutor, yeah, here are my credentials. The more important thing about this slide is I want you guys to know that math is fun, okay? Don't be scared of the subject. You need to practice and you need to do revision. So once you do practice and revision, I guarantee you it's going to be a lot easier. And once you start getting the hang of it and getting the questions correct, you will start liking the subject. Okay, I'm not like bullshitting you, it's true. So don't be shy to ask questions. In any point in time, if anyone is not clear on what's happening in today's class, you can always let me know. Okay, just to tell you more about myself, currently I'm obsessed with like this thing called Smiskies. I'm not sure if anyone here knows what this is. And I like cool and cute stationery, and I like my students improving. So some dislikes that I have is bihun. Yeah, I really dislike bihun. Please don't give me bihun. And yeah, when you are in doubt and you don't ask any questions. Okay, so for today's session, the main takeaways that I want you guys to have is you have to we can recap the key concepts together and identify common mistakes to avoid. So these common mistakes, right, more often than not, if you're not the one making, your classmate is probably the one making. So please make sure you don't fall under this scenario whereby you make these common mistakes. Then we also would identify common question types and methods to tackle them. And at the same time, I will also be going through some memorizing, checking, and tackling question tips. Okay, so a lot of these things are over here. Your school teacher don't have time to teach you because they are busy teaching you content. But what you can learn from this session is you can be able to see, oh, actually I can check my work using this method, and therefore I can be very sure that my answer is correct. Okay, once again, for those of you online, if you haven't have the worksheet, please go to the Google Drive and download it. Then we'll start with today's session. So today's session is A Math. Okay, this current session is A Math Sec 4. So if you are here for the wrong session, you may leave, or else, yeah, you can continue listening what I have to say. Okay, before I start today's lesson, anyone here have not learned trigo, ln, and exponent differentiation? Learn already? Okay, for those online, anyone here haven't learned? If you learn already, can give me a thumbs up, because depending on if you learned already or not, I will adjust the pace accordingly. Okay, I'm assuming everyone has learned it. If you haven't learned, you can give me a sad face. Okay, I'm assuming everyone has learned it. So before we even go through the content, you need to know, why are you even learning differentiation? Why even learn differentiation? Do you guys know what is dy dx? Okay, for sure, you all know dy dx is your first derivative. But dy dx is actually a formula that helps you find gradient of the curve at any point. In E-math, for you to find a gradient of a curve, you need to draw a tangent, right? Then you find the rise over run of the tangent. Dy dx, this formula, is for you to find the equation of the tangent without even drawing the tangent. This is why you're learning differentiation, to find the gradient at any point of the curve. Okay, that's why your gradient function, you can always suck in a x value. When you suck in a x value, you are finding the gradient of the curve at that one point. All right. So please be very clear on why you're learning differentiation. Because if you know what is the meaning of differentiation, sometimes when the question looks a bit different from your typical textbook question, but because you understand the definition, you will be able to adjust your steps accordingly. Okay, so dy dx is something called your gradient function. It is a formula that tells you the gradient at any point of the curve. All right. And take note, for differentiation, there are a few different kinds of presentation you will see. Please use the presentations accordingly to how the question gives you the question. All right. So if you see y equals to something x, you should be writing dy dx when you're finding your first derivative. If the question tells you like that, you don't go and write dy dx, okay? Because there's no such thing as y in this question. So simply, this is your presentation. Then, if the question tells you if it's fx equals to this, you should tell yourself your presentation for first derivative should be f prime x. So presentations do matter. I know you all know how to do differentiation, like the basic chain rule, power rule, quotient rule, product rule. Okay, it's pretty straightforward by now. But please be very mindful. If your presentation is inconsistent to the question, you will be deducted on presentation scoring. Okay, you'll be penalized based on your presentation. All right. So I'm not going to go through like in depth what is chain rule and product rule, all those. I assume you all know. If you all don't know, you can tell me. But what I want you to focus here is for log function, every time you're doing a log differentiation, you tell yourself, always apply your log rules to the max. Okay, you spam your log rules. Anyone here don't know what are log rules? Okay, your log rules are the things that you learn in the logarithm chapter. Okay, for your logarithmic differentiation to be easy, always spam your log rules first. I guarantee you it will make the question easier. Okay, and then for trigo differentiation, you need to tell yourself you can only differentiate sine, cosine, and tangent. So if you see something else like cosecant, cotangent, or maybe what's the last one? A secant. Okay, if you see any others other than these three, you must tell yourself you must convert it to sine, cosine, and tangent first. Then from there, you just apply the trigo rules of differentiation. Okay? Anyone here need me to go through the formula for trigo, log, and exponent differentiation? More or less, okay? Okay, if you need me to go through, don't be shy, let me know. Or else today, I will be focusing a lot on the application side because we have quite a lot of questions in this set of notes. And if you are all right with the basic rules of the differentiation, I will focus on the application side. Can Okay, if anyone unclear, let me know. Don't be shy. Ask me questions. Okay, product rule and quotient rule, the formulas are here. Anyone need me to go through? Don't need, Okay, so let's take a look at what I have over here, like so many question marks. Okay, can anyone tell me how would they differentiate this? What rule would they use? Okay, quotient, very obvious, right? So this one, you need to use quotient because there's something divided by something. But how about this one? What rule will you use? Okay. Okay, it's actually chain rule. Technically, you can use quotient rule, but tell yourself, there is no, there is no x term on your numerator. So if there is no x term over here, isn't it right to say that I can just rewrite it this way? Right? So it has become a chain rule question. So what am I trying to emphasize here? I'm trying to tell you that don't think that, oh, got fraction means confirm quotient rule. you ask yourself, fraction, but is it both the numerator and the denominator have an X term? If one of them doesn't have an X term, you can avoid quotient rule. And chances are, okay, rule of thumb is I will always tell my students, if you can avoid quotient rule, avoid it. Okay, because quotient rule is the most complicated formula. All right. Sometimes, okay, there are times whereby is this question, then you might want to use product rule. Also can, but my advice to you is if it's a fraction question, chances are doing it in quotient is going to be easier than doing it in product. Okay, because both of them still works. But later on, if this is a part A question, your part B, usually the answer for quotient rule will be easier to help you do your part B. Okay, so when I say rule of thumb, avoid quotient rule whenever possible, is when you have this kind of scenario whereby you can clearly avoid both quotient and product by doing chain instead. Okay, now moving on to these other examples. This one, what rule will you guys use? It's quite obvious, right? Yeah, there is something times something. So you will use product rule, okay? But how about this one? Would you also use product rule? Okay. Same thing, you could use product rule. Like this question, you could still use quotient rule, but there is an easier method to deal with this. If you simply do an expansion, okay, you do an expansion, can you see you can avoid product rule and you can just do term by term power differentiation? So what am I trying to say here? I'm trying to say that, okay, sometimes even though there's a product, maybe you want to start thinking of alternative methods. This one, you can easily expand. That's why you will opt for term by term differentiation. Whereas this one over here, can you easily expand? Not really, right? Because there's this irritating power over here. So you cannot expand it. That's why you no choice. This one is product rule. But this one you can expand. So you will do the expansion first, then do term by term differentiation. Okay? Now, over here, what differentiation would you use? Ask yourself. Yeah, okay. It is simply just a chain rule. Even though there is something times something, yes, but this something, this one is not a variable term. It's just a number 2. So this is just a chain rule question. You push the 2 out, right? Then you can clearly see that A is just holding to the power of half already. Okay? So your main takeaway over here is, yes, I know you know how to apply your differentiation formulas, but before you even start doing the question, ask yourself, is this the easiest method? Okay, can I do something to make the question simpler for yourself? Okay, in exam, right, your goal is to always use the easiest method and get the correct, accurate answer. Okay, you need to be strategically lazy in a way, all right? Now, let's look at this question over here. This is your trigo differentiation. Okay, this is your trigo differentiation. First things first is, when you're dealing with a trigo differentiation, okay, let me change up the question a little. Let me give like more concrete examples inside the bracket. Okay, for a trigo differentiation, I always like to tell my students to look as if like it's an onion like that. You are peeling out the outermost layer and then you are zooming in and differentiating after every layer. For this expression, can you all see the outermost layer is the power 3? Because technically cosine to the power of 3, okay, is also, you can also rewrite it in this expression. Can see that? Okay, so the outermost layer is actually the power 3. So you need to deal with the power 3 first. How do you deal with the power 3? Oops, sorry. How do you deal with the power 3? It's like a chain rule. So you need to drop the power down and reduce the power by 1. Can see that? So this is the first layer. Okay, you have dealt with the first layer already. Can you guys see? After the first layer, the outermost layer is out. The next layer is the cosine. So you need to differentiate the cosine term now. And this cosine term, can you see it will differentiate to become a negative sign? That's why over here, you must multiply by a negative sign, this thing in the bracket. Okay, you are literally going from outermost layer, which is the power, and then you're going to the inner layer, which is the trigo expression. Can see that? Okay, now there is one more layer that you need to satisfy. The innermost. Okay, so same thing. We now need to differentiate the innermost layer. And how do you differentiate this? It's just your algebraic term by term differentiation. So you need to go and multiply by 3x squared plus 2. Okay, so after all this, you will be able to get a final answer of 3 times 6x squared plus 2 times cosine square, write the entire thing in the bracket. Oh, sorry, there's a negative over here. And then there's a sign over here now. Okay, can you all see that? So usually, this kind of question is where students get stuck because they are like, oh my God, there's so many things to do. Got power 3, got cosine, where do I even start? You tell yourself, treat it like an onion like that. You are doing it layer by layer. Okay? So, this is how you would do your cosine chain rule differentiation. The same rules apply for sine and tangent. Okay? Okay, this next question is not differentiation. This one over here is I need you to be very careful. When you see this thing, okay, cosine 2fx is the same as cosine fx whole thing power 2. Okay, it is the same. But when you see something like this is no longer whole thing power -1. No. Okay, this is your cosine inverse. So it's a bit strange. Okay, I'll admit it, it's a bit strange. This is not the same thing as this. Okay, they are not the same. This is your inverse function. This one, can you see, is technically your secant? Okay, so be very careful. You will never be asked to differentiate this. You will never. But you will be asked to differentiate. I mean, you could be asked to differentiate this, which is actually just a secant. Okay, so if the question asks you to differentiate secant, okay, if the question asks you to differentiate secant, first of all, can you differentiate secant directly? Cannot, right? Because what did we mention just now? You can only differentiate sine, cosine, and tangent. So you must go and convert your secant to a cosine fx power -1 first. Take note, the power -1 is written outside. You cannot write it inside. Because when you write it inside, you are writing an inverse function already. Then from here, same thing, you just drop the power down, and then now your cosine, you can put the -2 in the middle now. It's very strange. Only -1 cannot put in the middle. Any other power you can put in the middle. Then you need to go and times a negative sign. Okay. Why need to times a negative sign? Because you are going in layer by layer. You deal with the -1 already, right? So the next thing you need to deal with is the trigo function. Then after this layer, there's one more layer, fx. So you need to also go and, okay, not enough space, but there's a multiply f prime x. Okay? So hope this clarifies any doubts anyone has so far. All right. If you have any questions, same thing, you can ask me or you can write in the chat box for those online. I will move on to the next page. Okay, so they ask you, for this particular equation, show that dy dx equals to this. It's pretty straightforward, okay? Why is it straightforward? Because it is simply just a differentiation product rule question. So can you try applying product rule on your own right now and try to show this? Okay, chances are your answer that you get at the very beginning will not look like this, but you can algebraically manipulate it such that it can be presented at this form at the end of the day. Okay? Same thing for those who are just joining online. The worksheet can be found in the Google Drive link sent in the chat box. If anyone joins later and cannot find the link, for those online, please help me do a favor. Tell them, hey, the link is there. Go and download it from there here. Okay. So for those of you who managed to do it, great. If those of you who need help, I will go through, don't worry. So how do you do differentiation for product rule? You keep one, differentiate the other, plus you differentiate the opposite term now, and then you keep the previous term that you differentiate. All right. So after you do the product rule, your answer will look like this. But take note, you need to present it in this form over here. So can you see this is actually a factorized form? Okay, so it means you need to go and factorize your answer. Take out biggest common factor. And you can see the biggest common factor is this thing over here. Okay, because you can use indices to take this thing out from here. All right. So after we take out biggest common factor, we just sum up the rest of the remaining factors. We will be able to get this over here. Okay, if this wasn't a shown question, this step could be your final answer. All right, usually for differentiation, the answer, right, if there is not a show question, they are more lenient. There are more than one possible answers they will accept. Okay, because sometimes you might leave your answer in factorization form, sometimes you might leave your answer in expanded form. But the rule of thumb is if you're super kiasu and you want to follow the answer key model answer, okay, the model answer will always be the most factorized, sorry, let me rephrase it, the most simplified form. What does most simplified form means? It means literally the answer looks the shortest, the simplest. Okay, and what does shortest and simplest looking answer mean? It means that you can fully factorize your answer if it's easy. If the fully factorized form is not easy, like very tedious to do or very difficult to do, it will usually be the most expanded form. Same thing, if the fully expanded form is super tedious to get or super like tricky or ugly, then it will be the most factorized form. You can take a look at your textbook answers, okay? When you flip your textbook solution, your differentiation chapter, the answers are always the most factorized or the most expanded. So either one is usually accepted, but you should, same thing, make your life easy. Choose the easier one to present as your final answer. Okay? And another question students might ask, do I leave my answer in indices or roots? Because technically 2/3 is square whole thing cube root, right? Okay, so the rule of thumb that I would advise you to follow is take a look at the original format. Can you see this question? They gave you in indices instead of giving you in 3 root. Therefore, your final answer should follow the format of whatever the question has provided to you. Okay, using these two logic combined together, I can more or less guarantee maybe 80% your answer will be the exact same as the model answer. All right, but same thing, in differentiation, the answer key is more lenient. There's more than one presentation they will accept, but if you want to play it super safe, you can follow this set of instructions over here. All right, now let's move on to part B. They say, hence find the second derivative, simplifying your answer. Okay, same thing. It's a very simple question. Because you already have your first derivative, you can easily get your second derivative. But what I want you to take away over here is an exam technique. Take a look at your part A. They already told you that dy dx is equals to this, right? If for the love of your life, you cannot do the first part, don't go and ignore the second question, okay? Don't go and give up the entire question. Because they already tell you dy dx is this thing, you should be able to try part B without even doing part A correctly. Because the answer is already provided. It's a show question. So what I'm trying to say here is, please in exam, open your eyes big. If you cannot do part A, it doesn't mean you give up the whole question. Take a look at part B first. Can you do part B given some hints provided above? Okay, you can, right? Then don't go and waste the entire question, the marks, okay? At least go and attempt part B as well. These are some important exam techniques you should know. So for part B, it's just a simple product differentiation question again, because you have one term times another term for your first derivative. So if you go and apply product rule correctly, you should be able to get this step over here. Same thing. Sometimes they will accept this as the answer, but if you want to play it safe, ask yourself, this thing, can you expand? You can, but is it going to be easy? No way, because your power is 2/3. How are you going to expand a 2/3, right? So, can you factorize instead? You can, because there's a common factor of this and this over here. Because there's a common factor, you can pull out common factor. Okay? So over here, okay, technically my steps over here, right, is correct, but it is even better if from the beginning, you guys pull out common factor of 2 as well. I a bit blind lah. I didn't see the common factor 2 there, but don't worry, because at the end, I pull it out. So it's the same thing. So you should take out the biggest common factor, which is this thing over here. How do you pull it out? This one is very obvious. You just take it out from this term. How do you pull this out from here? Is using your indices. Because -1/3 plus 3/3. Do I give back 2/3? You do, right? That's why over here, when you take this out as a factor from the second term, the leftover term is a 3/3. You need to use indices to help you pull out the biggest factor. So after you pull the factor out, you can start combining everything over here, because 3/3 is technically just power 1. And then after you combine, this is your other factor. Same thing. To make your answer the most simplified, you should pull out biggest common factor. Here, we can see another common factor of 10. That's why I pull it out. All right. And then, how come I leave my answer in root form? Actually can lah. This one also can. This is just a either or. In fact, hold on. This one will be better. Why will this be better? Because I'm following the questions format. But same thing, they will accept both. All right. These two, they will definitely accept. But this one, they might not accept because it's not simplified. Okay?
If I use indices,
if you use indices, yes, you need to factorize out the 10, because here can take out 10, right? Remember, simplified answer is either most expanded or most factorized. Sometimes when the answer key is linear, they could accept this as well. Hold on. Oh yeah, you brought out a good point. I didn't take out the 10 for my indices answer. Hold on. Let me change up my to make it better looking. Okay. Okay. There are times, actually, it's really quite hard to say lah. Usually, the answer key will accept, it will definitely accept these two, for sure. But this one, it depends on how lenient they are. They could accept it, they can don't accept it, I don't know. But if you don't know, right, play safe, must as well use either of the other two instead. All right. Now, let's move on to question 2. Question 2, sorry, if anyone needs the answer over here, let me show it for a few more seconds. Okay, just to take note, if anyone needs to take photo, can take photo for those attending it live, because I don't think the annotated answers will be uploaded. They will only upload the final answer key. Okay, so question 2, they say equation of a curve is this. Find dy dx. Should be quite straightforward, right? Just do differentiation of this and this separately. So this one is just your term by term. This one is your quotient rule. Okay? Can you all try it on your own? The solutions are out, but you can try it on your own. Question 2 a bit too simple already. Okay. Is it right to say that everyone use quotient rule for part 1? Okay, let me teach you something that you probably might not have seen it before. Okay, so if I tell you you can avoid quotient rule for this question, do you all know how to use that method instead? Okay, if I tell you you can avoid quotient rule. This question, you can avoid quotient rule. Quotient rule is correct, nothing wrong. But if I change the question, I say, find dy dx using term by term differentiation. Okay, using term by term differentiation. Can you see that term by term is no longer quotient? It's your power rule term by term. Okay, so how would I do this question if I say find dy dx using term by term? Okay, this is your y. The issue over here is this thing that is forcing you to use quotient rule. But we can always write this fraction into its partial pieces. Okay, partial fractions. But you don't need to go through the whole partial fraction process. You just need to either do long division to this, or you just need to do inspection. If you go and do long division, okay, you can try this on your own later on, you will get the same answer as me. But I want to teach you guys the inspection method. It's easier. Okay, can you see that if my denominator is x minus 2, I can force out a x minus 4 in my numerator? Okay, why am I forcing out a 2x minus 4? It's because, okay, why am I forcing this out? I'm trying to create 2 holes. Can see that? But I am not the examiner. I cannot change the question. Here is a minus 4 and here is a plus 5. Can you see I need to balance out with a plus 9? Can you all see that? I need to balance it out with a plus 9. And then I will have this over here right now. And this thing simplifies out to a, can you avoid quotient rule now? You can, right? Because over here is literally term by term differentiation. Okay, someone spot my mistake. Great. Yes, it's a minus 9. I put an extra line over there. Okay, but coming back to this second method that you might not seen in school before, can you see this is term by term differentiation now? And then dy dx is simply just 1 minus whole thing squared. So straightforward. Okay, so if next time you see another quotient rule question and you want to avoid quotient rule, some of my students, they die also don't want to use quotient rule. Then you can use this instead lah, other than the product rule method. Can? All right, let's take a look at, yes? Yes. How did I get from here to here so quickly? Okay, it's not because I copy answer, no. It's because when you differentiate x, it's a 1. You differentiate 2, it disappears. You differentiate this. This is technically this thing to the power of -1. So I just bring the -1 in front, and then my -1 must -1, right? So it becomes 2 instead. Yeah, so all this is like, because I do a lot of differentiation question before, that's why it's so quick. If you want to do it in one step as quickly as what I'm doing here, the only advice I can give you is you just need to practice. With more practice, you can see things very quickly, but same thing, don't be like me and make careless mistakes, even if I do it quickly, yeah? All right, so part 2, hopefully you guys realize is a chain rule question. Please don't go and use term by term, please don't go and use quotient rule. Quotient rule is still correct, you will get the correct answer, but you make your life more difficult. So why use quotient rule when you can use chain rule instead? Okay? Everyone all right with question 2? Can, if you need to take photo for those online. If not, I will move on to question 3. Okay, question 3, there are many parts, but I will just do part A, B, C, D today. Okay, part E is super straightforward. Okay, it's your exponential differentiation. That's the easiest. Part F, I'll leave it to you. The answers are already here. So write down if you need to, but I will not be going through part E and F today. Okay, so this purple color thing on the top, I already mentioned this just now. Usually, you leave your answer as the most factorized or most expanded form, depending which one looks nicer or is less tedious to do. For part A, you can easily see that it is a quotient rule question. So you just need to apply quotient rule. Okay, why is it quotient rule? Because you have a term that contains x in your numerator, and you have a term that contains x in your denominator. So confirm is quotient rule. If you really don't like quotient rule, you can push up the denominator and use product rule instead. Okay? So just do it accordingly. Just don't confuse yourself. Now you got log E and you got algebra together at once. So long as you follow the differentiation rules accordingly, your answer will be correct one. Okay, so here's the solution for part A. If anyone needs me to go through why is this the solution, you can always let me know. Okay, for those of you who are doing great, for those of you who need help, you can take a look at the solutions, but don't copy first. Take a look at where you went wrong, then try again on your own. This is how you can learn from your school teachers as well. Don't just copy their answer. You ask yourself, why am I wrong? And you compare your steps with your teacher's steps so that you can spot where your mistake is coming from. Okay, Okay, for those of you who join later, because at the first part of the lesson, I mentioned that I'm not going to go through the ln, exponent, trigo differentiation step by step. So if you haven't learned it in school and it's not tested in your WA, then sorry, you need to ignore all this for now. But if not, you can always rewatch the recording when it's uploaded to get a better understanding of what's happening after you have learned trigo, ln, and exponent differentiation in school. Okay, now let's take a look at part B. Part B is your ln differentiation for the first component. Can see that? And then this one is just your power differentiation. Remember, what did I say about ln differentiation? You max out every ln formula or rule you know before you even start doing the differentiation. I guarantee you, this will make the question easier. So, can you see that this thing over here, you can apply power rule to it? So you bring the 2 in front. If you bring the 2 in front, aren't you just solving a simple ln differentiation? Differentiation of ln x is just 1 over x. I have made the question easier because I apply ln rules first. Can see that? Okay. So how you differentiate is literally just like that, one step, because you apply ln rule. You can leave your answer in either format. Okay, if you guys did not apply ln rule, you still could do the question. So what will happen is your denominator will be a x squared, your numerator will be a 2x, right? And then you minus x squared like that. You could still get the answer, and the answer is still correct. But I guarantee you, when the question looks more complicated, this will not be the preferred method anymore. What do I mean by that? If I tell you y is equals to ln cube root 3x squared plus 5x, how are you going to differentiate this? Okay, if you use the dy dx equals to fx prime formula directly, is this going to be easy? Okay, it's not going to be easy, right? Hopefully you all know what I'm saying. You're very quiet for those online. Okay. So this question, if I ask you to find dy dx, it's not going to be that straightforward anymore because now your long function is more complicated. If you apply this formula straight away, it's still possible, but why go through the difficult way when you can always use the easier method? So, first things first, you should max out your ln rule. Can you see you can take out a 1/3 in front? Can see that? Then how to find dy dx is just 1/3 over 3x squared plus 5x plus, then the numerator will be 6x plus 5. As simple as that. Even if it looks tricky, tell yourself, spam your log rule. Once you spam all the log rules you can, this question will get easier and easier. Okay? Just to give another example. Hold on. Anyone want to differentiate this directly? Okay, this is additional example 1. This is additional example 2. Sorry, I know I'm a bit messy. Okay, anyone want to attempt to differentiate this directly? I don't think so, right? This literally looks like hell if you try to differentiate it directly. So what do? You spam your log rules again. When I say spam, it means you really apply as much as you can. Don't just apply it halfway, apply as much as you can. Can you see this thing will be equals to this over here? Can you all see that? Okay, but have I spammed out all my log rules? No, right? I can still use my subtraction law. So take note, you can still do this. Can see? Yes, okay. So I wanted to say something. This half over here, okay, it affects this entire thing. So a very common mistake is students just write this as the answer after they spam the log rule, but this is incorrect. You need to put a bracket. Okay, so this is a common mistake. I guarantee you, if you don't make this mistake in school, someone in your class will make this mistake. All right, so you need to put a bracket in front. Then after that, you can differentiate it very easily already. Your dy dx will be equals to half, because half is the constant, Then you put a bracket. 4x squared plus 2, because of this thing over here, then the numerator now is the f prime. So it's 8x. Then minus 3. Okay, here actually you can spam out more rules. Can you see that? You can pull the 3. So actually I should spam it first. Okay, I should pull out the 3 over here, and then I put an x here. Then it will just be a 3x like that. Okay? If you don't spam out all the rules, for example, okay, you'll copy this first. You'll copy this first. Okay, in the event you do not like fully spam out the rules, you could still get the answer. Okay, but you need to at least utilize as much rules as you can, such that you make the question simple enough for you. So if I didn't remove the 3 out, if I didn't, my answer will be x cubed in the denominator, and then 3x squared in the numerator. But at the end of the day, this also simplifies out to 3 over x. So you will still get the same answer. All right? So don't be too worried if you never spam out every single formula. All right? But you should be worried when you don't use enough formula to help you make the question easy looking. Okay? 10, yeah, because I add in a lot of additional examples. That's why we have limited time. Okay, for those of you who understand, you all can take a look at part C and try it on your own right now. Part C, right, is just a trigo differentiation. So, yeah lah, just now I already teach you. View the cosine 2 as like an onion like that. Okay, so if you, hold on, where's my solution? It's over here. Okay, so try it on your own first. The solutions are up. If you need help, let me know. For those of you who are done with part C, you can try part D on your own right now. Okay, so far everyone okay? If you understand, can give me a thumbs up. Wow, no one understand. That's bad. Then you come for nothing already. You don't understand. Okay, I'm assuming you all at least understand like 60% of it. Please don't scare me. Okay, part C, anyone has any questions? So view it as an onion, deal with the 2 first, then deal with the cosine, then deal with the 4x minus 1. It's really that straightforward. But just be very careful. Your cosine, okay, to become a sine, when you differentiate a cosine to a sine, there's a negative. That is another common mistake that a lot of students make. The negative just disappear. All right? Then your tangent will just become secant squared. Okay, for those of you doing part D, what is the first thing you need to do for part D? Can you see there's a secant?
Oh.
All right. So for part D, we have mentioned this just now. You only can differentiate 3 different trigo terms, right? You only can differentiate cosine, tangent, and sine. So if you see a secant, you need to go and convert it to a cosine first. But 1 over secant is simply just cosine. Can you see that? Because the reciprocal of a secant will be cosine. All right. So it is just this thing over here, and then you just do, you can use quotient rule or you can use product rule. For my solutions over here, I happen to use quotient rule. I happen to use product rule. Hold on, I see a question online. Let me answer that after after everyone is done with part B. Okay, same thing. For differentiation question, your answers can be like, in a way, the acceptable answers are quite subjective. They usually accept more than one. So even for this one over here, you can choose to pull out the 2 also can. You can choose to pull out the X also can. And then it will be something like that. So long as it looks the most simplified or simplified enough, it should be accepted one. Okay, this one confirm not very simplified, so you shouldn't leave it as, hold on, actually this one also rather simplified already, but it looks a bit messy lah, so maybe you want to like concise it a little to make it look literally more simple. Okay, so someone asks, for this question, can you apply double angle formula over here? You could, okay, you could, but you also don't need to. Because you apply double angle formula, yes, it shortens the solution. But while applying double angle formula, you are doubling the angle over here. So in a way, you're also making the angle less simple looking. Usually, the exam will accept both answers, so long as they are equivalent. All right, that's why it's very subjective and also a bit ambiguous. It's really by luck lah, see whether they accept your answer or not. But the rule of thumb is just make sure your answer looks simple enough, right? Most of the time they will give you the full solution marks. All right. So I'm not gonna go through part E and F. Same thing. The solutions are over here in green. You can try it on your own after class or at home. Let me move on to the next section, your applications of differentiation. When you are doing an application of differentiation question, you must always ask yourself, okay? You must always ask yourself, what chapter is the question from? Okay, don't just dive into the question and do dy dx immediately. Please don't, okay? Read the question and ask yourself, what chapter is this from? Of course, it's from differentiation, but is it testing you on tangent normal? Is it testing you on rate of change? Is it testing you on increasing, decreasing function? You need to ask yourself that first. Why? Because when you ask yourself which chapter it is from, it narrows down the different formulas you need. If it's a rate of change question, would you be trying to find gradient of a normal? No, right? If it's a rate of change question, you confirm know the t thing will appear somewhere. So you tell yourself, confirm got dt somewhere one, then you can focus on what to do next. So you know what to do next, then you don't feel stuck when doing a question. All right? So increasing function, what are they? It's literally when your function is going upwards. Because your function is going upwards, okay, the gradient must be positive. That's why your gradient function, remember at the very beginning of the class, I explained what is dy dx, is a formula talking about a gradient. So if your function is increasing, your gradient function must be positive. When your function is decreasing, your gradient function must be negative. Then for stationary points, your dy dx is equals to 0. Why is stationary point your gradient function 0? Because stationary point means your point stop. Like literally the thing is moving, the coordinate is moving. Then it suddenly stops. Then it changed direction. That's why when it stops, it's called stationary. And this is why you have your stationary point. Dy dx is equals to 0. Because when you stop, the gradient is 0. Like you stop moving, from go down, go up, you stop moving at one point in time. Be very mindful. There is a difference between stationary point and turning point. Stationary point, you got 3 types. Minimum, maximum, inflection. I'm sure you all have heard this by now. But turning point, inflection is not a turning point. Okay? Inflection is not a turning point. Your turning point only got 2, minimum and maximum. So, why am I telling you all this? If the question says, can you determine the nature of the turning point? If the question tells you determine the nature of the turning point, and you do first derivative test and you get inflection, confirm something is wrong. You need to go and check your work because it's a turning point already. So if you get inflection, go and check everything you have so far. All right. Now, for turning point, your second derivative test cannot be equals to 0. This one, can you remove it? Okay, can you remove it? It could be equals to 0. Okay, because when your second derivative test is equals to 0, it just means that it is inconclusive. It doesn't mean that it is not a minimum and maximum point. Okay, it is just inconclusive. Be very mindful of the difference. So this one is a typo. You have to remove this. Okay, so anyone here don't know how to do first derivative test? Okay, everyone know. These 3 rows are compulsory. If you don't have these 3 rows in your table, okay, you will be penalized for presentation. The last one is not compulsory. Okay, the last one you don't need to write a table for it. You can just say therefore minimum maximum point or therefore point of inflection. But this 3 is compulsory. And then over here, if your x value, for example, is 5, okay, your x value that you use over here cannot be too big. Okay, rule of thumb is at 0.01. I know some schools they say at 0.1 is okay, minus 0.1 is okay, but I'm telling you it's safer to choose a smaller number. Those of you who are interested to go JC, okay, adding 0.1 might affect your answer, but adding 0.01 will probably not affect the accuracy of it. So just take note. Why must you choose a very small number or why must you choose a very small number to add and minus? It's because you are actually looking at the gradient very close to the stationary point. If you choose a very big number to add, for example, over here is 5, then I go and say, this one I put as 10. Okay, 10 might be over here. Okay, 10 might be over here. And can you see the gradient from supposed to be negative become positive? Then you will get an inflection in state already when the correct answer is actually a maximum point. That's why you must choose a very small number to add and minus from the stationary value, from the x value that gives you the stationary value of y. Okay, please be very careful for this. Don't go and add like 1. 1 is not safe enough. You need 0.1 is the maximum. But that's why I say safer, do 0.01. That one is confirmed safe. Okay, second derivative test, I'm sure you all know how to do it. But the question is, when do you do second derivative test? And when do you do first derivative test? Okay, my rule of thumb is, if your dy dx looks like a very simple expression, like something like this, you should do second derivative test. Because to get the second derivative is so straightforward, so there's no harm doing second derivative test. Can see that? Okay. When your second derivative is super complicated, when your first derivative is super complicated, something like this. Wow, cube root square plus 5x over 4x square plus 1 to the power of 7 over 3. If this is your dy dx, would you want to differentiate this again? Not really, right? So when your dy dx looks very complicated, you wouldn't want to get a second derivative. Therefore, you should opt for first derivative test. Okay? Everyone clear? Don't waste time trying to do second derivative test when your expression for dy dx is so ugly. Why? Because second derivative test is not a foolproof method. You could get an inconclusive situation. So if you are super like Yasu, like you don't want to come to the scenario whereby you will get an inconclusive statement, then the rule of thumb for you is do first derivative test. But if you like to choose the easiest method whenever possible, take a look at your first derivative expression. If it's simple, then why is there's no harm to trying second derivative test because it's so fast. Okay, take note, when your second derivative test is equals to 0, it is inconclusive. You cannot say that it is a point of inflection. You cannot. You just have to go back and fall back on first derivative test instead. It is not a point of inflection 100% of the time. There are times that it could be a minimum or maximum point that happen to escape the second derivative test. So please be very careful, okay? So when do you use which test? This is one way to identify. If your first derivative is easy to differentiate, you will go for second derivative test. If your stationary value, the corresponding x value is equals to 0, you might want to opt for first derivative test as well. Okay, why would you want to opt for first derivative test when your x value is equals to 0? Because there will be a very high chance that your second derivative test will be equals to 0 when your x is equals to 0. Can see that? Then it will mean that your second derivative test is inconclusive. So if your x value is equals to 0, there's a high chance your second derivative test will fail. Can see that? Therefore, maybe you just want to do first derivative test that will definitely work from the very beginning. I know a lot of you don't like to do first derivative test. I also don't like because need to draw this irritating table. Okay, quite waste time, right? But sometimes doing the table from the beginning, from the start, will help you save time just by taking a look at the situation that's happening. Okay, so now let's look at the. Okay, never mind. There's a shy teacher. Hold on. Okay, so this one, don't say that you heard it from me, all right? But sometimes you can play cheat. Okay, what do I mean by play cheat? If the question say the value of A is maximum and prove that it is indeed a maximum value. You've seen this kind of question before, right? This kind of question, if you need to prove that it's maximum and you have no time in exam, you can play cheat. You just literally do first derivative test and draw the maximum scenario happening. All right, you didn't actually suck in the values, but you play cheat lah, because you know it's maximum point already. Then you just play cheat, draw this table, and then say, hence, we can show that it is maximum. So only do this play cheat method when you have no time in exam. Okay, only when you have no time. Why? Because what if you really suck in your values and you know that you're supposed to get a maximum, but after you suck in, you get a minimum point instead? It means that the x value you found here is wrong already. So by doing this maximum checking, okay, doing it really substituting the value in, you can spot whether you have any careless mistakes or not at the top. Okay, so only use the play cheat method when you have no time in exam. If you have time, do the substitution diligently so that you can check whether your answer on top is correct or not. Okay, these are some useful exam techniques that you probably won't hear from your teacher lah. Your teacher won't ask you to play cheat on. Okay, so everyone here know what's a tangent, right? Tell yourself, dy dx is not just the gradient of a curve, it is also the gradient of the tangent. Okay, so when you want to find gradient of a tangent, you can always use dy dx. If you want to find the gradient of a normal, you cannot just use dy dx. Normal, there's always, okay, when you see the word normal and when you see the word curve, you must always tell yourself there is a middleman called the tangent that connects the two of them. Okay, you cannot jump from curve to normal. You cannot jump from normal to curve. You must always have this middle piece called a tangent. All right, why? Because your curve has the same gradient as the tangent, but your normal is perpendicular to only the tangent, not the curve. Okay, so every time when you see the word normal in the question and you see that there's a curve given, you tell yourself, you confirm need the gradient of the tangent or the equation of the tangent somewhere to connect and complete the question. All right, so everyone should know this formula. You all should have learned this in what's that called? Coordinate geometry in Sec 3. If you don't know this formula, ask me after class. All right. So how do you find the gradient of a normal versus gradient of a tangent? Tell yourself it's always just a reciprocal and then put a negative sign in front. That's why it's called a negative reciprocal. Okay, so when you see a question that has tangent, normal, and a curve, immediately you should start thinking of finding gradient of tangent and normal, and then finding equation of a line. An equation of a line requires two things, a gradient and a coordinate. Okay, so tell yourself, if the question is asking you to find equation of any line, be it a tangent or a normal, you always need the gradient of the line that you're finding for and also a coordinate that lies on the line. If you have these two pieces, you will be able to find the equation of a line with no problem. Understand? Okay, moving on to the last application type of question, which is the rate of change. Rate of change question, tell yourself, okay? Hold on, let me erase all this in case it's very messy. Rate of change question, I know that some schools, they teach different methods. If you are comfortable with your teacher's method, go ahead and stick to your teacher's method. All right, but I guarantee you, this method over here is the easiest one to, sorry, not even this one, sorry, hold on. Okay, this one, okay, because full disclosure, this notes is not written by me, but I can guarantee you the one that I'm about to say is going to be the easiest method. So can you all cancel this if you want to? All right, what you should always do is, for a rate of change question, you tell yourself, you should always look at find the dependent variable first. Okay, I'm sure most of you here are science students, right? You all should know what is a dependent and independent variable. When we draw a curve, okay, is the y dependent or the x dependent? The y, right? Because it's on the y-axis, it's on the vertical axis. Because y is the dependent variable, you let dy dt be alone on the left-hand side. Always let the dependent variable be alone on the left-hand side. For a rate of change question, it is always a three-component equation. It's always something on the left equals to something times something on the right. It's always three components. For a rate of change question, they will definitely ask you to find one of the component in this three component equation. And they will tell you the other two. Okay, they will give you enough information for you to find the other two. So, if the question tells you the value of dx dt, you write down dx dt as one of the components. Okay, then how do you find the last component? You balance the equation out. How are you going to get a y and t alone on the left-hand side? Can you see you need a y here? Then you need an x here? Because if you cancel out the dx, you do indeed get a dy over dt on the right as well. Okay, but you cannot actually do the cancelling lah. I guarantee you, this method of forming a rate of change equation is the easiest. If the question is asking you for dx dt instead, still form this equation. Then to find dx dt, you take this divided by this value and you can find dx dt the answer as well, even though dx dt is not the subject over here. Same thing, if you are more comfortable with whatever you have learned in school, you can use your school method, not to worry. But for those of you who are still confused in this chapter, I guarantee you, this one is the easiest method you can use. There are times whereby the dependent variable is not clear. For example, I tell you there's pressure and volume. Okay, when there is pressure and volume, it's not very clear whether volume or pressure is dependent, which one is the dependent variable. So when it's not very clear, the one on the left-hand side will be the one the question asks you to find. If I ask you to find rate of change of pressure with respect to time, then it will dp dt on the left. Then your here will be dv dt and then times dp dv, because I am asking you for pressure over time. Okay, only when it's not clear, the one alone on the left will be the one that you need to go and find for the question. All right, so hold on. Yeah, so writing this method, okay, if you use this method instead, you will also avoid the division scenario, which is harder to visualize. So this statement is still accurate, all right? I mean, nothing here is wrong, okay? Nothing here is wrong. It's just different ways of viewing the question. Okay, now that I've mentioned rate of change, I just finished rate of change, right? Let me find a rate of change question first, and let's do the rate of change question first. So now, since it's still fresh in our mind. Okay, let's take a look at question 6. Okay. Question 6, we jump to question 6 first, because question 6 is a rate of change question. Before we do any differentiation question, same thing. You ask yourself, what chapter is the question from? Take a look at this question. Can you see, because there are time units involved, there is t involved, that's why it is a rate of change question. Okay, so let's do part A first. Okay, but before we do part A, can you read the question first? Okay, part A asks you to express x in terms of r and show the shaded area A is given by this formula. Okay, the shaded area, it is area of the triangle minus area of the circle, right? Does anyone here know how to find area of the triangle? It's an equilateral triangle. Okay, we know that the base is x, right? Can we find the height? One way is to use Pythagoras theorem to find the height. Okay, because x over 2 is this piece, and then the hypotenuse is x. But this is actually the harder method. Okay, the easier method is ask yourself, area of a triangle. How many formulas have you learned to help you find area of a triangle? Yeah, okay. There is a trigo formula that you have learned before. So you can use trigo here. And you should use trigo here because you know that the angle is 60 because it's equilateral. So area of the triangle is half sine. Okay, technically it's sine 60, but because it's a differentiation question, you should always do it in radian. Okay, I'm sure you have seen it in school, right? When you do a differentiation question, your trigo is always in radian mode. So as much as possible, leave your answer in your workings in radian as well. So it's x squared. This is the area of the triangle. Then what is the area of the circle? Super simple, right? Pi r squared. Can see that? So technically, the area, okay, this one let me simplify. Sine pi over 3, you all still know what's the value? Yes. Okay, it's like that, which is this one, not a trigo recap session, so I don't have time to help you go and memorize this, but you should know. Okay, there's a way to memorize to help you get the values immediately one. Oops. So can you see this is the area of the triangle now? And this is the area of the circle. So the area of the shaded region is this thing minus this thing, right? Okay, but take a look at your part A. There's some weird formula instead. Okay, this minus this is the area formula. But you need to show this instead. Okay, you need to show this instead. Can you see what is the main difference? Can you all see what is the main difference? Yeah. Can you see that the x has disappeared? So how do you make the x disappear? You need to make an expression that x is the subject and in terms of r. Then after that, when you do a substitution, then you can say that this is shown. Can see that? So this is a very, very typical differentiation question. They like you to show a particular equation equals to this first, then they ask you to do the differentiation later on. So how do you show this equation? Is first of all, take a look at the question and take a look at the, take a look at the question and take a look at the theoretical formula. What is the difference? The difference is that the x disappears. And because the x disappear, you need to make an equation whereby x is the subject and in terms of the terms, which is r, that only appears. All right, this is how you should structure the question in your head. This is the formula, the question one. This is the actual formula. What is the difference? The difference is that the x is missing. So I need to find an expression of x and replace it in terms of r. Okay? How are you going to... Okay, it's very obvious. From here, we can see that x is equals to r plus 7, right? But we cannot just write this out of nowhere. We need to prove that it happens. Okay? This question is not that easy, but for those of you who managed to get an idea of it already, great. They say that x has an initial value of 10. And they say that r has an initial value of 3. It's not 10 minus 3, then you get 7. No, some of you might be thinking of this. But take note, both x and r are increasing at the same rate. Can see that? So at any point in time, can you see the difference of x and r must always be 7? That's why x minus r equals to 7. That's why x is equals to r plus 7. It is not because of 10 and 3. No. It's because there's a constant difference of them being 7. Understand? This is the explanation already. Yeah, they'll allow this. Okay. So someone asks, do we need to explain anything? Don't need, because this is the explanation itself. Okay. So over here, we can say that x is equals to r plus 7, and then we can just plug it in and we can show that the formula is, we can show the question already. There's a not so good presentation in my work. I should write A instead of area. Okay. So this thing is a hint. So take note, because we know that x is equals to r plus 7. We just need to push ourselves to go and prove it. Okay, part B, they say, hence, find the rate of change of the shaded area. Can you see the question is asking you to find dA dt because they want rate of change of shaded area. And shaded area is represented by A. Can see that? Okay. Can you see that A is the subject, is the dependent variable, and can you see that R is the independent variable? Can see that? That's why dA dt should be alone on the left. Okay, then we know we need two other components. What two other components should we put in? Tell yourself. You should put in what the question has given you. Can you see the question has given you dr dt? That's why one of the component must be dr dt. Then the last one, what do you need? You balance out. It will be dA dr. Because if you know that dr dt is one of them, because it's given to you, then the only way that this thing will balance out to give you this is if the last component is a dA dr. Can see? Okay. So, how do you find dA dt? The trick for rate of change question is, if I ask you to find this thing in the three-component equation, you don't focus on the thing. You don't focus on this. Okay? If the question asks you to find this, you should spend your time and energy to find the other two instead. It's always like that. Okay? I guarantee you. If they ask you for dA dt, don't go and try finding dA dt. Find the other two components instead. Then when you have these two, you will get this already because you have the equation out. So if our focus is these two instead, do we already have dr dt?
Yeah.
Okay, we do. The question has provided to you. So this checks out. So in other words, at the end of the day, we only need dA dr. Okay, can we find dA dr? Take a look at your part A. You have found the equation of A in terms of R. Can you find dA dr? Can, right? Then go and differentiate lor. Then after you differentiate, you will have dA dr. Okay? But the issue now is, you have dA dr, but it is in terms of R. Can see that? You still need to go and find the R value for substitution. What is the R value? It is not 3, yeah? Yes, okay. Some of you already got it right. Because they say shaded area after 20 seconds. So your initial radius is 3, but it's growing at 0.2 per second, right? So your R will be 3 plus 0.2 times 20, which will give you a 7. Now that you have your R value, do you have your dA dr value? Have, right? You can just suck in. And if you have your dA dr and your dr dt, can you find your dA dt? Can, right? It's just a multiplication because you already formed that three-component equation. Okay? Can, Anyone has any questions? Yeah, very quiet. Okay, so the solution is negative 6.37 cm square per second. Please remember to put your units, okay? They are important. If the question is slightly different, they say, hence, find the rate of change of decrease of the shaded area after 20 seconds. Your answer is no longer the same, because I say I want the rate of change of decrease, you need to remove the negative sign. Okay, I'm sure you have heard this in school before. If you haven't, it's not your teacher never teach, it's you just miss out. Your teacher will definitely say this. So if the question say rate of decrease, you have to remove the negative sign as your final answer. So you will say rate of decrease equals to 6.37 cm square per second. Okay? Rule of thumb for rate of change question is always form the three-component equation first. Okay? If you form the three-component equation, you will be able to make your life a lot easier because you know this is the equation. If I ask you to find this thing over here, okay? If I ask you to find, hold on, let me erase this. If I ask you to find dr dt instead, you tell yourself, you should focus on finding the other two, and then when you push this to the other side, when you have the values, when you push this to the other side, you will still be able to find dr dt, even if dr dt is not the subject. Okay, you can switch it around at the very end. Dr dt need not be the subject. The subject, to make your life easy, should always be the dependent variable over time. Okay? So this is how you will do question 6. Okay, because of the lack of time, I will go through question 2, 3, and 4. I will skip question 1. So let's move on to question 2 right now. Okay. Okay, question 2. They say a gardener uses 2 meters of fencing to enclose 2 flower beds. One bed is an equilateral triangle of side x, and the other is a circle of radius r. Express r in terms of x. Okay, so this one, I cannot really give you any exam tips. You just need to really use the scenario provided and help yourself make r the subject in terms of x. You know that the total is 20 meters, and you know area of a triangle and perimeter of a triangle and perimeter of a circle, which is your circumference. You all know the formula already. So you write that first and equals to 20. Then from there, you rearrange the terms such that you make r the subject. Okay? So this is how you do part I. Part II, they say, show that the area of the 2 flower beds can be represented by this formula. Same thing. Ask yourself, area of the 2 flower bed is the area of the triangle plus area of the circle. Okay? But can you see that one variable is clearly missing? R is missing. Can see that? So all the r's were replaced by the x. And can you see? Therefore, you need to utilize this part that you found in I to help you do II. Okay? We have already done area of an equilateral triangle just now. Hopefully, you can try part II on your own right now. How do you find area of an equilateral triangle? You can use trigo. Okay, 60 degrees, but same thing, you should leave it in radians. So it's pi over 3. All right. Try it on your own first. Okay, and then all the r needs to be replaced out because you don't see any r over here, and we already have the formula out in part I. So versus question 6 that we did just now, part I wasn't there. We need to realize part I on our own when we do the area formula part. Okay, so over here we have the formula out. And then we just need to algebraically manipulate and squeeze out the formula that they want us to show. Okay, simple as that. Any questions, can let me know. Okay, let's take a look at part 3. Given that x can vary, find the value of x, which gives a stationary value of a. Take note, you can do part 3 even if you did part 2 wrongly. Okay, why? Because the formula for A is a shown question. It has been provided. So same thing. Don't go and skip the whole question, even if you cannot do the first part. Take a look at the later parts. You can still do it. So don't miss them out in exam. Okay, and this question, they only ask you to find the value of X. So if they ask you to find the value of X, please don't waste time and give me the value of A. I'm not asking for the value of A. Okay, stationary value of A. Every time you see the word stationary, okay, you must tell yourself, the first derivative must be equals to 0. Okay, stationary value, stationary point, confirm. The thing you need to do is first derivative equals to 0. And in this context, the first derivative is dA over dr. Okay, dA dr. So you need to go and find dA dr. Sorry, not dA dr, say wrongly, dA dx. Okay, you need to go and find dA dx, and you need to let it be equals to 0. Then from there, you can solve for the value of x already. All right? So how I find dA dx? I literally just differentiate A in terms of x. It is not a quotient rule question. Please don't go and use quotient rule. Why? Because your denominator over here is a constant. You can just push it out and then you will get a term by term differentiation. This one is power rule. This one is chain rule. Okay? Then at stationary A, dA dx equals to 0. That's why you will let this thing over here equals to 0 and you can solve for x by making x the subject. Take note of my presentation, super important. I have a 3SF value, but I also have a 5SF value. Why is there a 5SF value? Because this is not the last part of the question. Chances are I need to use my answer for part 3 to help me find my answer in part 4. If I only have the 3SF value and I sub it in later on, I am at a very high risk of rounding off error. Okay, so always rule of thumb, write your 3SF answer, yes, but also write a 5SF answer if it's not the final part of the question. Okay, chances are you need to use a higher accuracy answer for later on. Very important, it's a bit wasted to lose any solution marks based on rounding off error. Okay, then from here, our answer is 4.15. Rule of thumb is to have always 2SF more than the final answer. At least 2SF. You can have 6SF, 7SF also can. It will still work. All right? You want to use exact value even better. But sometimes the exact value a bit ugly. So it's very hard to key into the calculator. Okay? Okay, moving on to part 4. Find the nature of this stationary value and explain why the gardener might be disappointed. Okay, so this question, you need to go and find nature of the stationary value. Nature means either minimum, maximum, or inflection, right? So you need to go and find it out. Which one is the case? Because they say stationary value. Stationary value, it means that it could be inflection because it's not turning value. Okay, it's a bit weird to say turning value. That's why usually you'll see stationary value. So you can either use your first or your second derivative test. Take a look at your first derivative. This is your first derivative. Is it easy to differentiate? Okay, it looks complicated, but it's actually very simple because there is only a x term. Can see? So when you differentiate this thing, It is simply just this times this. So it's very straightforward. So you should opt for second derivative test instead of first derivative test. Okay? But if your second derivative test fail, then too bad lah. You need to do first derivative test later on. Okay, that's why if you are scared that it fails, you must as well do first derivative test to begin with. This is only if you are scared of it failing. Okay, so I choose to do a second derivative test, and I don't even need to sub in the value of x actually, because the x disappear ma. It's very obvious that this value over here is going to be bigger than 0, and therefore the nature of this stationary value is a minimum value. Okay, this one a bit weird. Like, explain why the gardener might be disappointed. Okay, the gardener is disappointed. I mean, because it's might ma, so you can just give any random reason that makes sense. Okay, the gardener has the smallest area for his flowers. Hence, he might be disappointed because it's a minimum value, it's a minimum area. So with a smaller area for your flowers, the gardener might be disappointed. The fact that the question is saying the gardener might be disappointed is also a hint to you that it's going to be a minimum value. First, you ask yourself, will the gardener be happy to have more area, or happy to have, or be happy if the area is minimum? You might think that naturally, you might think that the gardener wants to have a bigger area for his flowers, right? So he would want maximum area. The fact that he is disappointed would hint to you that this is a minimum value question. Okay, sometimes the question will give context one. This one is not very obvious. But for example, if the question states, A is the area needed to paint the figure. Okay, then explain why the nature of A would lead to cost efficiency. The fact that A is the area to be painted, and they say explain why the nature of it will lead to cost efficiency, is a very big hint that it's going to be a minimum area. Because cost efficiency means that you want to paint as little area as possible, ma. So what you guys can do in the exam to help yourself is pick up all these little hints along the way. Sometimes you don't have enough time to do your second or first derivative test, so you play cheat lah. You go and write therefore minimum point using your first derivative test, because you can get the hints that it's going to be minimum at the end of the day anyway. All right, but same thing, only play cheat when you have no time. Now, let's take a look at question 3. Yes? Yeah, sure. There's a toilet outside. There's a, yeah, you'll see, you can't miss it. It's a wooden door. Okay, let's take a look at question 3. Question 3 says that fx is defined for this function, and this is the expression for, hold on, for f prime x. So it's already f prime x. Part I, they ask you to express this in this form, f prime x in this form. We have actually done this question just now already. Just now, remember, to avoid quotient rule, what did I do? I split up the fraction, right? So this question is asking you to split this up. It's not asking you to differentiate, because be very careful. Here is f prime. Here is f prime. We are not asking you to do any differentiation. Okay? So you split it up by doing inspection. Or you could also do long division. Okay, why can you do long division? Because this is a improper fraction. If you use long division, you will get a quotient and you will get a proper fraction. All right. Oops, sorry. I'll leave it up to you guys which method you want to use, but the answer is this one over here. Okay. Now, let's take a look at part II. Determine, or hence, sorry, say wrongly. Hence, explain whether fx is an increasing or decreasing function. The fact that they ask you whether increasing or decreasing function, immediately you need to think of your formulas, the concepts that you have learned. Increasing function means first derivative must be bigger than 0. Decreasing function means first derivative must be smaller than 0. So to explain whether a function is increasing or decreasing, you need to prove that your first derivative is indeed positive indeed negative or indeed positive. Okay, this thing over here is a or, it's a slash in case anyone is confused. We already have this expression out. I'm not sure if it's obvious to you, but this thing over here must be a positive value. Why? Because 5 is positive. And take a look at the question. They say x must be bigger than 3 over 2. So if x is bigger than 3 over 2, can you see 2x must be bigger than 3? And if 2x is bigger than 3, can you see your denominator here is always positive as well? If your denominator is always positive, can you see with a positive numerator? Sorry, I keep pressing wrongly. With a positive denominator and a positive numerator, your whole fraction is going to be positive. So if you have something positive plus something positive, naturally, you will get an overall positive scenario. And if the whole thing is bigger than 0, you can say that fx is an increasing function. Okay? Take note, it is not f prime that is increasing. It is fx that's an increasing function. Because f prime is bigger than 0, it would mean that fx is an increasing function. Do not mix up the logic. This is very important. Okay? Now, let's move on to part 3. By considering the second derivative, that means you need to go and differentiate one more. Explain whether the gradient function is increasing or decreasing. Hold on, yeah.
The minus sign goes to the next.
Last 6. Oh, sorry. Yes, there's an error over here. Here is a +6. Good that you spotted. Okay, great. Okay, so over here is a 6. But it doesn't affect the answer. But yes, don't make these kind of mistakes. Okay, but moving on to part 3. Considering the second derivative, explain whether the first derivative is an increasing or decreasing function. Okay, this question is a very common exam question. It will not look like this in every single exam, but the logic is the same. You ask yourself, to prove that fx is increasing or decreasing, we look at first derivative. To prove that second derivative, let me rephrase. To prove that the first derivative is increasing or decreasing, can you see you need to go to the second derivative? Okay, because to prove that this is whether increasing or decreasing, we look at this value, right? So to prove that this is increasing or decreasing, we need to look at the one more derivative of it. So we look at the second derivative. It's the exact same logic, but the subject here is no longer fx, but your subject here is f prime. That's why you need to look at second derivative. Okay, you need to adjust your logic a bit, you need to adjust the level of derivative you are at, but the logic is the same. So by considering the second derivative, they give you a hint already. Okay, so you must use your second derivative. This question can be super irritating. What they can say is, they can just give you this instead. Explain whether f prime is an increasing or decreasing function. They can just throw you this question. And you on your own should know that you need to consider the second derivative. Because fx, whether is it increasing or decreasing, you need f prime. So if you want to determine whether f prime is increasing or decreasing, you need to go one level more for your differentiation and you need to consider second derivative on your own. Usually in exam, when they test you part 3, they will not provide this thing for you. So you need to know on your own. Okay? So how do you go and find second derivative? Straightforward lah. You already have your first derivative already. Sorry, because my answer here got error. So here also it will be a 6. Okay. So when you find how to find your second derivative is just your first derivative, you differentiate one more time. And this is your second derivative. And, okay, everyone here should know that a square number is always going to be positive. Okay, the fact that your denominator is always positive and your numerator is going to be negative. So can you see the whole fraction is going to be a negative fraction? So this thing, right, will always be negative for all values of x. Therefore, if this is always negative, second derivative is always negative, we can prove that the first derivative is going to be a decreasing function. All right? Just to reiterate, part 3 is not a textbook formula. Is you utilize your textbook formula of increasing, decreasing functions and you apply it to a slightly different question. That's why when you see a question that's a bit different, don't be alarmed. You have learned the necessary concepts before. You just need to tweak it accordingly. Okay? So this is question 3. Okay, due to the lack of time, I have to rush to question 4. Question 4, if you guys haven't learned exponential or trigo differentiation, you can skip it, okay? Because you require this exponent and trigo to do this question. They ask you to find the equation of the normal to the curve at the point. Okay, they ask you to find the equation of the normal to the curve at the point x equals to pi. So, equation of normal, you should tell yourself, you need 2 things. You need gradient of the normal and you need the coordinate on the normal, right? Because you need 2 things to find equation of any straight line. How do you find the gradient? You do dy dx because that is your gradient function. Okay, so after we find dy dx and we sub x equals to pi, we can find the gradient. But is this gradient of the normal? No, remember, normal and curve always got a middleman. That's a tangent. So this gradient over here is the gradient of the tangent. You need to do a negative reciprocal to find the gradient of the normal. All right? So this is the gradient of the normal. So what you're lacking is the coordinate now. We already know the x coordinate. We just need to find the y coordinate by substituting the x into the equation. Okay, sine pi, you all should know by now, it is 0. So e to the power of 0 is just 1. So we know that there is a coordinate pi comma 1. And we can substitute it into this equation over here. And we can find the equation of the normal. All right, it's as straightforward as this. Usually, you will not leave your answer in 3SF because it's a bit weird for equation of a line to be in 3SF. So you'll leave it in exact. Can? Okay. Take note, the gradient over here is gradient of a tangent, not the normal. So you need to do a negative reciprocal. Oops, sorry, I keep pressing wrongly. Now, let's take a look at part B, the last question of the day. The curve, this particular curve, has a minimum point at -1. Find the coordinates of the other stationary point and determine the nature of a point. Okay, part B is totally not related to part A, so don't mix the question up. You can read on your own and realize that they are not related at all. Okay, this question is what I like to call a confirm full mark question because you can check your work. Okay, how do you check your work when you're doing 4B? First of all, you need to do the question lah. Okay, they tell you that there is a curve, okay, and there is a minimum point at x equals to -1. They tell you to find the coordinates of the other stationary point. So to find the coordinates of the other stationary point, can you see you need to let dy dx equals to 0? And then when dy dx equals to 0, you can solve for the x coordinates. Can see that? Okay, one of your answer for x must be x equals to -1. If you do not get the answer, one of them as x equals to -1, confirm something on top you did a careless mistake. Because the question already tell you that there is a minimum point at x equals to -1. So if you don't get that x equals to -1 as one of the solutions, you know that confirm something is wrong. But if you do, then you can be quite confident that the other solution you have is correct. So this is what I mean by you can check your work. But of course, I mean, sometimes it's quite sway one. You get -1 here, yes. But over here, you have some careless mistake, then you write some other x value. Then that one too bad. But take note, you can use this method to check your work that you're on the right track or not. So because they ask you to find the other stationary point, you need to go and find the x and y coordinate. Okay? Now, the last part, they say determine the nature of the stationary point. What will you guys use for this question? Will you use first or second derivative test? Okay, you will use first. Okay, you can use second because this is not that difficult to differentiate. It is just two product rule at once. But take a look at your x value. Your x value is 0. So there's a very high chance that your second derivative test will be inconclusive. Therefore, why take the risk when there's a high chance of it being inconclusive? And you can just do first derivative test straight away. Okay, I did it over here to show you that it's inconclusive. But in exam, you should tell yourself, hey, very high risk to get inconclusive, so don't waste time, do first derivative test instead. Okay, and this is the answer for question 4B. For those of you who are still here, please stay a little longer because I need you guys to help me do a survey. Please don't leave. I know it's the end, but help me do the survey, okay? All right. Hopefully today's lesson helped you a lot more in terms of understanding how to start off a differentiation question. What are the differentiation question types? And based on the different types, what is your first step? Because if you know it's going to be a stationary question, then you know set dy dx equals 0, that is confirmed the first step, then you move on from there. If you know it's a tangent normal question, you know, okay, confirm got this middleman called a tangent, then I will have to relate normal to tangent, then to curve, then I can solve the question accordingly from there. If it's a rate of change question, first things first, always create the 3-component equation, and then if the question asks you for 1 component, your focus should be on the other 2. This is always the idea you should have when you even do any questions. Don't jump into the question. Ask yourself which chapter first, then select the different concepts you need to help you do the question. Okay? Then also, hopefully all the checking and tackling tips you guys managed to get a good understanding so that if you see something of similar scenario in future questions, you can apply it to that, to those questions. Okay, so right now I need to do some admin matters. So if you like today's session, don't worry, okay, don't need to join any group tuition. But if you like the session, you like my teaching style, you can contact me at this number over here, and these are my current classes. So technically, this one is a Coven A Math class lah. So yeah, if you are here physically, this is where the center is at, and this is where the A Math Coven class will be held. The location is here, and then these are the timings. If you are interested, these are the lessons that I have. Okay, we have other math tutors as well. The timing will be different. So if you don't like my class, you prefer another math tutor class, also can. No worries. I assume most of you here are overmarked students. I know not all of you, but yeah, if you are not an overmarked student, these are the what's that called? The tuition details that might be of interest to you if you are if you want to join any tuition class, not just math. Okay, but the more important thing here is I need you guys to help me scan this and do this survey. So actually, I'm not very sure exactly what is the questions in the survey, but I believe it's a feedback form. Okay, so help me do this feedback form before you leave. And if you have any questions, feel free to stay back and ask me. So I believe the questions are surrounding like, oh, do you want this kind of events in the future? Is it helpful? How's the teaching like? Okay, you can be honest. Don't need to say it's good if it's bad. But if it's good, don't go and say it's bad lah. Then that's all for today. The final answers will be uploaded into the Google Drive. The Google Drive link will be provided in the Overmarked Telegram group, but the annotated answers are not provided. So if anyone needs the annotated answers, you have to let me know now. Annotated answers will only be provided for the questions that I've went through. So question 5 and 6, I cannot provide you the annotated answer because we want to encourage you to do it on your own first. Okay, then that's all for today. If you have any questions,